As the UK moves towards a low-carbon future and we start to see fewer fossil fuels like gas and oil, distribution network operators like Electricity North West need to plan for the extra demand in electricity we're all likely to need. Using fewer fossil fuels means we'll start to use more electricity for heating and running electric vehicles, so demand for electricity will rise significantly. This will place a huge demand on our network. The costs of upgrading the network to carry more electricity will mean higher bills for customers. So, we're trialling smarter, more affordable ways of using the existing network, which will reduce costs for all our electricity customers in the future. In recent years, we've seen many smart solutions applied to our high-voltage networks to make them more efficient. But most of our customers are connected to low-voltage networks, which have not yet seen the same application of smart technologies. One of the challenges of running the electricity network at present is a drop in voltage as electricity flows through the low-voltage networks. Low-voltage networks operate within a set range, the statutory voltage range at which we must deliver electricity to our customers. To achieve this, the sending voltage at the substation is set high enough so that the voltage at the farthest point from the substation is within the required range. But this means that voltage at the end of the circuit is lower than the voltage closest to the substation. Customers' appliances, such as fridges and washing machines, are designed to run at an optimum voltage, at which they consume the least energy. This means that if the voltage is too high or too low, the appliances use more energy than they need and cost more to run. In the future, customers will also use an increasing number of low-carbon technologies, such as solar panels, electric vehicles, and new electric heating systems. This will make maintaining voltage within statutory levels more difficult. With the help of groundbreaking technology and software, our innovative low-cost solution, smartstreet, will change this. By combining the new technology with our existing network, smartstreet will increase our ability to deliver more network capacity to our customers. This will enable them to connect their new low-carbon technologies, help the network and customers' appliances perform more efficiently, save them money, minimize fuel demand, and reduce CO2 emissions. So, how does smartstreet work? smartstreet applies centralized management which, for the first time, allows our network to be truly responsive to customers' needs. Remote-controlled devices installed on the low-voltage network will allow us to detect changes in demand and automatically respond to them. The network is continually adjusting to meet customers' needs in the most energy-efficient manner. The voltage on the network changes throughout the day, depending on how much electricity customers are using. smartstreet responds to these changes in real time, always maintaining voltage at the most efficient level for customers' appliances, saving them money and reducing CO2 emissions. smartstreet is designed to solve this problem by changing the way we deliver electricity to customers. By actively managing the low-voltage network to respond to their needs, we can ensure their appliances operate as efficiently as possible. The brains of smartstreet is a central intelligent network management system. This measures the fluctuating demand for electricity from our customers and issues commands to other technologies installed on the network, such as on-load tap-changing transformers, capacitors, WEZAPs, and links devices. These technologies will work together to balance voltage and meet the daily electricity needs of our customers. Let's fast forward to the year 2035 to look at a day in the life of smartstreet. It's midnight, when most of us are asleep. Electric cars charge slowly, while heat pumps are on low settings. smartstreet technology constantly monitors and measures the network. At the moment, voltage is set at a lower level so that customers can benefit from their appliances using less electricity. It's now 6 a.m., and as we start to wake up, heat pumps are heating our homes. We start to use more electricity, having showers and making breakfast. smartstreet detects an increase in demand and uses capacitors and transformers to manage the voltage level. At 8 a.m., we start to leave for work. Demand for electricity in homes and residential areas is falling. Elsewhere on the network, in offices, shops and factories, demand is increasing as we arrive for work in our electric cars. Plugging in our electric cars and using computers, heating and air conditioning at work is starting to affect the voltage level. smartstreet detects this increase in demand from its light industrial and commercial customers and manages the voltage by enabling capacitors and transformers to respond. By 10 a.m., most domestic houses are using a minimal amount of electricity. As the sun comes up, solar panels, a source of renewable energy, start to generate electricity and export any excess onto the distribution network. smartstreet recognizes this increased voltage and connects this part of the network with the nearby light industry circuit via a links connection. This means all customers served by the two connected circuits can share capacity. The high demand on the light industry network is supplied by the excess electricity generated by the solar panels on the domestic network. The transformers and capacitors work together to keep the voltage stable. At 1:30 p.m., the network experiences a momentary drop of voltage. A WEZAP immediately detects this potential fault on its circuit. It sends a signal to the network management system showing where the fault is on the cable. An engineer is automatically scheduled to attend site the next day to carry out a repair before a fault occurs and before customers are affected by a loss of supply. At 2 p.m., solar panels start to reduce their output, which reduces voltage on the network. Later in the afternoon, we start to leave work and make our way home. smartstreet detects these changes and uses transformers and capacitors to maintain the voltage on the network to cope with the fluctuating demand. By 7 p.m., most of us are at home. We plug in our electric cars. We start to use electricity to cook evening meals, watch television, and use computers. Now, the load is shared by the two connected circuits works in reverse. Increased demand on the domestic circuit is offset by the low demand on the light industry network. Transformers and capacitors continue to respond and maintain the voltage level. After 9 p.m., demand on the domestic network is much lower as we use less electricity. Some of us are watching television, while some of us are going to bed. smartstreet recognizes this and changes the voltage on the domestic network to adapt to the drop in demand. The smartstreet cycle will continue to respond to our fluctuating need for electricity as we see changes in our daily lives, in our seasons, and in our climate. This innovative approach will help keep costs down for customers, reduce carbon emissions, and help to get the most from the existing network. smartstreet, creating efficient distribution networks.